Hello and welcome to our programme Q&A webinar. Today's session will cover the MSc in Medical Physics and we have our panel here to chat through all things medical physics. We are recording the session so that will be sent out in the next few days and I'll post some helpful links into the chat box as well. We've got an upcoming postgraduate event which will cover things like scholarships, accommodation, finance, so there'll be some useful links there for you. So yeah, let's get into it. Would you all mind introducing yourself? So Claire, would you like to kick off?
Sure, I'm Claire Tarbert. I'm a medical physicist in the NHS. That's my main day job. And then I also help to run the MSc in Medical Physics at the university. So I've got an honorary position at the university and I'm the programme lead for the MSc here. Mark, I'll hand over to you.
Okay, thanks. So I'm Mark McJury. I help Claire to run the MSc. I work for the NHS. I'm a clinical scientist sitting with the MRI team, and I similarly hold an honorary position with the University of Glasgow.
Perfect. Claire, so you mentioned you've got some slides. Is it worth just opening up those and then running through those?
Sure, so let me check I can share my screen here.
Hopefully we've set it up properly.
Yep. That one there, yes. Can
Sorted.
you see that just now?
Perfect.
Okay, great. So yes, that's just the title slide. I've already said this here. So I was just gonna start with a little bit of background about our MSc in medical physics, depending on what your background is as somebody who's interested in applying. This will hopefully provide some helpful background to you. So the MSc has been running for over 30 years at this point. So it was first developed or it's been running in some form for more than 30 years. And it was first developed in 1993, or that was the first year it was run, as part of a postgraduate training scheme in the NHS. So the intention for the MSc at that point was to provide the background knowledge and understanding that somebody who wanted to work in the NHS as a medical physicist, the kind of the knowledge and understanding that they would need in order to go onto a programme of work-based training. And over the years, that training scheme has changed. It's now called the Scottish Medical Physics and Clinical Engineering Training Scheme. And people who do go onto that training scheme, the successful endpoint is HCPC registration as a clinical scientist. So over the years, this MSc has been developed, and so is that training scheme. And the MSc now is recognised and as a standalone element that's got value not just to the NHS but to international applicants as well. So the core, the foundations of medical physics and clinical engineering are the same whether you're working in Scotland or England or Mexico or Greece. And so we've had increasing interest from international students over the years. One thing to point out is that this MSc is just focused on that background knowledge and understanding. So the MSc does not include the work-based training that's required in order to progress onto HCPC registration. And what we recognise as well is that, you know, not everyone who takes our MSc is interested in a career in the NHS. This is some data from one particular year, so it's not standardised or it's not aggregated over a long period of time, but these are the typical places that students in one year of our MSc have gone on to work afterwards. So in one year we had quite a high number who went on to do this work-based training scheme in the NHS in order to become NHS physicists. We had a cohort who were looking for jobs in medical physics outside of the UK. So that's typically our international applicants who maybe want to work abroad afterwards. We have most years quite a few who will be looking to apply for PhDs in either medical physics or an allied field. We've got people who will apply for other types of jobs in the NHS, and we've also had a couple who've wanted to go on after doing this, having a background in physics, having done this MSc, then wanted to go on and train to be a doctor of medicine rather than a doctor of physics. Just a couple of things to point out. Typically, our student cohort is quite small, so we've had anywhere between 3 and 13 students. So that can be quite good for the students as well, because you get a lot of our time and input. And you also get to know each other really well. So it's generally quite a tight-knit group that leaves our MSc at the end of it. And we offer informal career sessions throughout the year. So Mark organises those. We typically have a couple of career sessions where we will invite in either people who've done our MSc in the past, or people who have and gone on to work in other fields, or people who who have just found a different way into a career as a medical physicist, whether that's in industry, academia, or in the NHS. So we offer those throughout the year as well. So Mark and I mentioned that we are both clinical scientists within the NHS, and that's true of most of the teaching staff on this MSc as well. So we do have, the MSc has been developed and is delivered in collaboration between the NHS and the university. And we do have some core teaching that's provided by sort of purely academic staff at the university. And so that type of teaching is teaching in anatomy, and teaching in research methods and statistics. But the vast majority of our courses are delivered by frontline NHS staff, so about 80% of that. And again, that can be really positive for students as well, in that what you will be hearing about is the absolute latest clinical application of any techniques we're talking about. So whether that's nuclear medicine, whether that's MRI, whether that's the application of computing science within the NHS. So that can be a real positive. On the other side of it, it does mean that they're rushing back to a busy clinical service after they've delivered the lecture to you as well. So there are pros and cons to that. So who are we then? Well, who is this group of staff within the NHS that's doing this teaching? We refer to ourselves as the Department of Clinical Physics and Bioengineering. Very often sort of use the acronym of DCPB. And we're a relatively big department. So the NHS in Glasgow itself is one of the 3 largest NHS organisations in the UK. So there's a couple of trusts in London, some in the north of England, but we are one of the biggest NHS organisations in the UK. And it really is huge. So we cover a population of 1.2 million people. So that's the majority of the population in the Central Belt in Scotland. We have something on the order of 38,000 staff. And we have 35 hospitals, and our budget is over £3 billion. So it's really huge, the NHS in Glasgow itself. And as a kind of knock-on effect from that, our physics and engineering department is one of the biggest in the UK as well. So we have something like 330 staff at the moment, and our main remit is to provide scientific and technical support to the NHS in Glasgow and beyond as well. We cover all of the kind of core areas of medical physics. So those would be things like radiotherapy physics, equipment management, nuclear medicine, radiation protection, diagnostic radiology, and MRI. And because we're such a big health board, and because we have such a large physics and engineering department, I mean, again, there's pros and cons to that as well. But what it does mean that is if there's something interesting going on in one of these fields, if there's a new development in radiotherapy, if there's a new development in MRI, it's highly likely that we'll have some application of that within Glasgow. So we'll be involved in that in some way. So that can be beneficial to the MSc and the students who are taking that as well. So just to give you a sort of flavour of what our services do, again, they are absolutely huge. We have our radiotherapy physics service actually extends beyond just the core population in Glasgow, and it's a regional service that provides radiotherapy for, well, it covers a population of 2.6 million people, and that's just a huge service. So they're delivering 7,000 courses of radiotherapy per year, which equates to about 300 individual treatments per day. Our MRI service, which Mark spoke about, is huge as well. So we support 24 clinical MRI systems in Glasgow, and we also we're the only facility in Scotland that has one of these, has a high field strength 7 Tesla MRI scanner as well. And we're one of only a handful of those in the UK as well. So there's, I'm not sure of the exact numbers right now. And our nuclear medicine service is huge as well. So we have 18 gamma cameras spread across the city, and as well as 2 PET-CT systems, both in the Gart Naval campus. Our radiation protection and diagnostic radiology service is supporting more than 800 pieces of diagnostic radiology equipment. So that's CT scanners, X-ray systems, fluoroscopy systems. And our equipment management system is also one of the biggest in the UK, and we manage more than 60,000 medical device assets. So that's a kind of huge logistical undertaking for that team. So that's a kind of flavour of who we are that's doing the teaching. But what you would want to know what's actually in the MSc. What would you be learning? What's the kind of nuts and bolts of what you'd be learning if you do decide to sign up for this course? Well, it's a kind of standard MSc format in as much as it's, in order to be awarded the MSc, you complete 180 credits of modules. There's 120 credits of taught courses, and those are split roughly evenly between the first and second semester. So you do 65 credits of taught courses in the first semester and 55 credits in the second semester. And then over the summer, you would undertake the final 60 credits, which is in the research project. And the programme, the taught courses themselves are split up into a mix of, first of all, topics on general scientific skills that you would need as a clinical scientist working in the NHS. So things like anatomy and physiology. We don't expect you to have any background in anatomy and physiology when you undertake this programme. We're expecting the people who take this programme to have a good understanding of physics through an undergraduate degree, but not necessarily any anatomy and physics background. We would teach you research methods and statistics. So statistics are a key basic skill for any scientist working in healthcare. And then finally, we have a programming for the clinical scientist course. That's a 10 credit programming course. And the reason for that is programming is a key skill for any physicist, and that includes physicists working in the NHS or working in healthcare. So as well as those general topics, we also have the specialist subjects, and that's where we deliver this kind of specialist knowledge that you would need to work specifically in a medical physics department. So we have in the first semester a radiotherapy physics course, and that covers it's exactly what it sounds like. So it covers things like imaging in radiotherapy, dosimetry, treatment planning. We have the first of 3 imaging courses in the first semester. So that's the Physics of Medical Imaging 1. And that course is really the physics of imaging that uses ionizing radiation, everything except nuclear medicine. So that's the physics of CT, the physics of the physics of fluoroscopy, the physics of X-rays, the legislation that we need to be aware of around those things. And then in the second semester, we also have 2 more imaging modules. So we've got the Physics of Medical Imaging 2, which is really the physics of MRI and nuclear medicine. Clinical imaging, which is the clinical application of imaging. And then we've got 2 courses which are more on the clinical engineering spectrum. So that's clinical measurement and scientific management. And after you've completed all of that in the second semester, we try to bring that together in the research project. So the research project itself starts in April after the semester 2 exams, and it's intended to give you an opportunity to apply some of that those taught courses, or what you've learned in those taught courses, into a real world research project. So it's typically something, if it's a mix, it's usually a mix of projects either in the NHS or at the university. And if it's in the NHS, it's a project that our department needs to improve our clinical services. So very often we'll have a mix of topics that we're able to offer you. So this year we've got projects in radiotherapy, we've got projects in MRI, data mining, and in nuclear medicine as well. And all of that would then be assessed via a written dissertation, a poster and a presentation, and a viva as well. Just say a little bit more about assessment, because assessment of that's assessment of the research project is via a written dissertation, poster and presentation and viva. The taught components, the assessment is via a mix of written exams and coursework, and the general split across the 120 credits of taught components is about 60% of the assessment is via a written exam and about 40% is via coursework. The coursework, the nature of the coursework will vary from course to course. So just a couple of examples would be in the programming course rather, the coursework might be a mini project that you're doing. For our evidence-based biomedical research methods and statistics course, the coursework is a research proposal. So you'd be asked to write a research proposal. And then some of the other courses would give you problem-solving sheets that you need to complete over the course of a couple of weeks. Okay, so just a few points on logistics. Our teaching is typically split between the main campus and the Teaching and Learning Centre, which is at the Queen Elizabeth University Hospital. I'll show you a map of that just on the next slide. So it's mainly split between those two sites. It's probably about 85%, 80 to 85% in person. We do have some pre-recorded lectures that we use for some of the courses, but it's primarily in person. And then we would also expect you to visit other sites for some of the practical work and the tours that we'll offer throughout the year. So this is just to give you an idea of, this is showing you a map of central Glasgow. The main campus is highlighted here, and the Teaching and Learning Centre is just over a little bit to the west and in the south of the river. So it takes about 20 minutes to cycle between those two sites, and it's about an hour to walk. There are good buses, but it's not a huge distance. And then these are some of the other sites that you would visit throughout the year. So the New Victoria, we would send you to for a practical session over there. And the GRI, the Glasgow Royal Infirmary, it's about 5 miles away from the QE. We would send you there for one practical session during the year. And we do try to get you into clinical settings as often as we can, although we're limited by kind of restrictions on space and the availability of clinical staff and equipment. But in semester one, at a minimum, we would have a practical session in a CT suite where we'd have you scanning a phantom or being supervised to scan a phantom and changing parameters on the CT scanner. We would have an ultrasound practical where we would talk you through an ultrasound machine and then get you to scan somebody's carotid artery. And then we would also have a couple of tours and practical sessions in our radiotherapy, at a radiotherapy clinic. In semester two, we've got a tour of an MRI suite, and we do a practical session there as well. We've got quite a long gamma camera practical session. It lasts a whole day, split between the morning and afternoon. We would get you to tour some of our clinical measurement services, and we would also take you over to our PET radiopharmaceutical production unit, or our cyclotron. The research project is probably the best opportunity for you to get into either an NHS department or a university department and do some practical work. And the type of practical work that you would be doing would vary from year to year and project to project, but very often it'll contain a practical component in an NHS facility. So for example, image acquisition on an MRI scanner or replanning radiotherapy treatments. So I've just got a couple of one final slides here, Naomi. These are some of the questions that are often asked. So how many hours or days are you likely to be on campus? Our timetable is quite jam-packed, and we would actually expect you to be on campus 5 days a week with about between 2 and 4 hours of classes per day. So it's quite intensive, and luckily we have nice facilities, so it's hopefully a nice place for you to spend your time. Do you get your access to material before class? So all of our slides for our lectures should be available on Moodle or online learning environment at least 24 hours in advance. A small number of the courses do, as I say, are delivered via pre-recorded lectures with follow-up tutorials, but it's quite a small fraction of the overall content. And then the final question, well, there are 2 final questions. One that's not on this slide: how do you recommend having a part-time job, or what's the balance of having a part-time job? We have had a couple of students who've had part-time jobs in the past. What I would say is you have to be quite careful about the amount of time that you're dedicating to the job. This MSc is quite intense, and while you might only have 2 to 4 hours of classes per day, what we are expecting you to be doing is spending the rest of your time studying and working on coursework and these kind of things. So you do need to be quite careful with your time. And then the final question there: how to start preparing for the MSc. One, I think, generally helpful thing to do is some general interest background reading on medical physics, and IPEM is a good starting point from that, the Institute of Physicists and Engineers in Medicine. And then the final bit of advice that we always give to people is to think about how you might approach a different style of teaching and learning than you would have had encountered in your undergraduate physics degree. So what I mean by that is, very often if you're coming out of an undergraduate physics degree, the amount of content you had to absorb was relatively small. So the challenge with an undergraduate physics degree is understanding concepts, and then applying these concepts in a problem-solving environment in the exam. So you maybe have to understand a particular theory, you have to remember a set of equations, and then you have to be able to apply that theory and those equations in a written exam. But you don't have to remember a huge amount of material. And with our MSc, the nature of medical physics is we need to teach you an awful lot of information. We need to teach you things like anatomy and physiology, and we need to teach you the clinical application of nuclear medicine. And the feedback we get from our students is that there's typically a lot more content than you would have in an undergraduate physics degree. So starting to think how you might approach that and how you might adapt your learning to this different style of delivering teaching, or the different content that we're going to be delivering to you. Okay, and is there anything else, Naomi, that we could?
I mean, I think you've covered a hell of a lot of information there, that all the questions that I had kind of pulled together that we typically do get asked have been covered, and plus a few extra things there. Mark, I don't know if there's anything that you think's been missed or that you'd like to maybe touch upon.
No, I mean, Claire's done a great comprehensive job. I'm lead for the research project, so it's actually 3 months. It used to be 4 months on the slide there, but it's 3 months now. But no, I think Claire's covered it all. You know, that project is, as Claire said, is a great opportunity for people to finally apply all their learning during the year, and to choose whether they want to do it in an academic environment or in a clinical environment. And usually, you know, it depends on where they're heading next. So yeah, I think it's usually an enjoyable finish to the course.
Yeah, I know when I've spoken to students, a lot of them, when you ask it what's that you've enjoyed most, a lot of them is their research project, because they've kind of got a bit more flex with it to sort of learn more about what they want to kind of maybe do afterwards. Yeah.
Yeah, I
Here, were
think
you going to add
that's what
something
we
there?
find as well. Yeah, I think we find that as well, and it's a completely different environment, and they're working with different people. So it very often brings out a kind of different element of the student as well. It's a different, you know, it's this opportunity to apply the knowledge that's learned, but it's also a different environment and working with different people, which I think they really enjoy. Yeah.
Yeah. One thing that's maybe worth mentioning is the cohort for this class is quite small, but that doesn't mean that you don't have opportunity to meet with other students. We've got so many clubs and societies. There's also loads of other ways just to meet other students and get involved with them, and even wherever you're staying, there's the chance to meet there. So I wouldn't be concerned about that. You'll have lots of opportunity to mingle and network.
Yeah, and we definitely see that with our students as well. So the core group is a very tight-knit group, but they also, as you say, like they make friends through living in halls and wherever they're living, in clubs and societies. Yeah.
Yeah, it's hard not to meet people.
Yeah.
I think that's a nice it's a place to just wrap up there. What I will say is, if you've got any questions after watching this webinar, you can still ask questions. We've got the administrator email address on the programme webpage, so do send any questions there, and we will get back to you. The administration teams are brilliant at picking up those emails. But yeah, if you do have any questions, please don't sit in silence. But yeah, thanks very much, Claire and Mark, for taking time out of your very busy days to join us for this webinar, and hopefully we'll see you all soon in September. Thanks very much. Bye bye.
Thanks, Naomi. Bye.